If you happen to look up at the sky this week, you might see a rather surreal mix of the natural and the highly engineered. Welcome to episode 432 of AI Brief. I'm Amin.
And I'm Leah.
Off in the distance, you might catch one of the last blood moons we'll see until late 2028. But human-made objects in the sky are starting to look like vintage science fiction.
Picture a completely UFO-shaped electric aircraft hauling half a ton of cargo over a city, or a massive floating power plant tethered thousands of feet in the air.
Today's main points cover a massive spectrum. We've got OpenAI's new classified deployments, fire tornadoes cleaning up oil spills, methane turning into medicine, and airborne wind energy. It's a true deep dive.
The overarching theme here is the sheer velocity of deployment. We're looking at a moment where aerospace, molecular chemistry, and AI are bypassing the theoretical phase and moving directly into real-world infrastructure.
Let's transition to today's new updates. That transition from theory to infrastructure is nowhere more apparent than the major headline from OpenAI.
They've officially reached an agreement with the U.S. Department of War to deploy AI models directly onto their classified cloud networks.
We are strictly looking at the engineering and logistics here. How does a consumer-grade artificial intelligence actually bridge the gap to a highly secure military server?
The logistics of that bridge are, well, they're incredibly complex. A classified government cloud isn't pinging servers in a public data center.
Because they're entirely air-gapped from the public internet to prevent breaches.
The implication there is OpenAI isn't just granting API access. They're likely having to provide the underlying model weights and architecture to be containerized.
To run locally on the Department of War's own internal hardware. But if these networks are isolated, how do you continuously update the model?
That is the core engineering hurdle. In an air-gapped environment, the model itself remains static for longer periods between highly secure manual patches.
Because part of what makes these models powerful is the continuous ingestion of new information.
But the value for the Department of War isn't scraping the public web. It's turning the AI loose on their massive internal troves of classified data.
Enhancing data analysis, intelligence gathering, and high-level decision-making.
We're talking about cross-referencing thousands of satellite images, intercepted signals, and field reports in seconds. The AI becomes a localized synthesis engine.
It doesn't need the public internet when it's fed a constant stream of secure intelligence. But the computing power required for that must be staggering.
It necessitates a specialized hardware infrastructure, heavily reliant on advanced GPUs deployed within those secure facilities.
Moving AI from a novel consumer tool to foundational architecture.
Which is a monumental shift.
Let's transition to everything else in AI today and the broader tech landscape. I want to move from hidden architectures to something intensely physical and born from a completely chaotic accident.
Back in 2003, a bourbon warehouse fire led to a massive spill into a nearby retention lake. The combination of alcohol, fire, and weather created a 100-foot-tall fire whirl.
A literal tornado of flame. And now, researchers are using the fluid dynamics of that exact phenomenon to clean up ocean oil spills.
Controlling a destructive force to mitigate an environmental disaster. They are purposefully engineering fire tornadoes over oil spills because the combustion dynamics completely outperform traditional methods.
These spinning flames burn oil 40% faster than a conventional fire pool, where oil is simply corralled and ignited on the surface.
A traditional fire pool creates an immense amount of thick, toxic black smoke because the oxygen only reaches the outer edges of the flame,
leading to incomplete combustion. How does forcing the fire into a tornado shape physically change the burn?
It comes down to oxygen entrainment. When you force the fire into a spinning vortex, the rapid rotation acts like a centrifuge, aggressively pulling oxygen in,
funneling it directly into the core, which superheats the center of the vortex.
That elevated temperature leads to near-complete combustion. The fire whirl consumes up to 95% of the spilled fuel and cuts toxic soot emissions by 40%.
To test this, engineers built a 16-foot triangular structure in Texas to channel the air. But translating that to the open ocean seems incredibly difficult.
The ocean is defined by unpredictable, high shear winds. Structural fragility is the primary limitation. Fire whirls collapse quickly in strong crosswinds.
So engineers would need to design a floating mechanism to shield the fire from ambient wind while still precisely funneling air.
It is a massive fluid dynamics challenge. But controlling the flow of oxygen brings us to another radical transformation.
Hispanic scientists taking natural gas and turning it directly into medicine. It feels almost like alchemy.
Methane is abundant, but its carbon-hydrogen bond is notoriously stable. The industrial standard is often just flaring it off, burning it into the atmosphere as waste.
Breaking those bonds usually requires massive refineries and immense heat. But researchers are using an iron-based catalyst and LED light to create a hormone therapy medication.
Through a mechanism called photocatalysis. The iron-based catalyst acts as a receiver. When LED light hits it, it excites the electrons.
Generating enough energy to snap those stubborn carbon-hydrogen bonds at room temperature.
Once broken, the methane can be synthesized into complex molecular structures. The economic implications are profound. You drastically lower the cost floor for drug manufacturing.
Turning atmospheric waste into a high-value biological resource. That kind of resourcefulness requires us to look at the space around us differently.
Which brings us back to the objects in the sky. Engineers in Wuhan are testing an electric vertical takeoff and landing aircraft that is shaped like a classic flying saucer.
The world's first ducted ton-class flying saucer design, meaning it can lift roughly half a ton of payload on battery power.
They are targeting 2026 for commercializing this for urban logistics and aerial rescue.
Dropping half a ton of cargo into a tight urban environment sounds risky. Why a flying saucer shape instead of a traditional helicopter?
A traditional helicopter relies on exposed rotor blades. In an urban canyon, a blade strike against a building is catastrophic. The saucer design utilizes ducted fans.
The blades are entirely shrouded within the aerodynamic body. The outer hull acts as a physical bumper.
It also prevents blade tip vortices, which increases thrust efficiency and dramatically dampens the acoustic footprint.
Pushing boundaries vertically also applies to energy, like the S-2000 floating power plant.
A helium-filled craft floating 6,000 feet up, tapping into high-altitude winds that are exponentially stronger and more consistent than ground-level wind.
It generated enough electricity on its maiden flight to power an average home for nearly 2 weeks. But how do you securely transmit high-voltage power from a floating blimp back to the ground?
The tether utilizes ultra-strong synthetic polymers, similar to Kevlar, to handle the mechanical tension woven around advanced conductive alloys for electrical transmission.
A miles-long extension cord that doubles as an anchor line. It allows dense, land-scarce regions to tap into reliable, clean energy simply by reaching higher.
Reaching higher seems to be the mandate everywhere today.
Let's transition to our final content segment, today's trending AI tools.
The sheer volume of software updates occurring simultaneously is dizzying. We have a massive list of tools that just dropped.
Framer, Claude in Excel, Notion Custom Agents, Perplexity Computer, TypeBoost, Migma, Rover by rtrvr.ai, and Opal 2.0 by Google Labs.
What's particularly revealing about this list is the lack of accompanying descriptions. The industry is iterating at a pace that is outstripping its own documentation.
Products are shipping faster than comprehensive use cases can even be published. You blink, and 8 new tools embed autonomous agents into your workflows.
The macro takeaway is the shift from destination AI to integrated AI. We're moving away from visiting a separate website to ask a question.
Tools like Claude in Excel or Notion Custom Agents embed models directly into our foundational software.
And names like Perplexity Computer and Rover suggest agentic behavior, software that navigates your operating system to execute multi-step tasks autonomously.
The landscape is shifting daily. Let's bring this deep dive to a close. We've examined the architectural shift of OpenAI deploying massive language models onto classified servers.
We explored harnessing fire tornadoes for oil spills, photocatalysis turning methane into medicine, ducted fan flying saucers, and tethers pulling electricity from the clouds.
The boundaries of what constitutes a resource are expanding rapidly.
I want to leave you with a final thought. We analyze scientists taking a destructive fire tornado and engineering it for environmental cleanup. We looked at methane being transformed into medicine.
It forces a broader perspective.
What other elements in our world, currently categorized as dangerous or waste, are merely waiting for the right technology to unlock their hidden value?
A phenomenal question to end on. Please make sure to follow and share the podcast if you enjoyed this deep dive.
Thanks for tuning in. See you in the next episode.